All right, hello, welcome back. In these next few lessons, we're going to be looking at more polynomial functions, but in this case, we don't have any of the roots. We don't have it broken up. So what happens when you need to list all of the zeros or x-intercepts? Well, we're going to be able to use something called synthetic division to break down a polynomial function. And let's look at the first one. So x plus 3 is divided by x cubed plus 6x squared plus 5x minus 12. So we're going to use x plus 3 to divide it into x cubed plus 6x squared plus 5x minus 12. You could use the long division format, but synthetic division is quicker and easier. So the point that you're going to divide into, you're going to take the root of x plus 3, because x plus 3 is a factor. Therefore, it has a root, which is x equals negative 3. That's going to go right here. And then you're going to take the leading coefficient of each of these leading coefficient of each of these not factors, but can't think of the word. So you're going to take the leading coefficient of x cubed, 1, leading coefficient of 6x squared, 6, leading coefficient of 5x, 5, and negative 12 is just negative 12. So this is negative 12 times x to the 0. So you're going to take the leading coefficient of each one. So if x cubed is the highest, but you're missing an x squared, and it just jumps to 5x, you're going to have a leading coefficient of 0 x squared. So you're going to have to put 0 for there, sort of as a placeholder. But we'll see that later on. Now, the first step we take once we have it set up is we're going to move the 1 down here, because negative 3 can't go into the first one. And then we're going to multiply negative 3 times 1, and we're going to get negative 3. We're going to place it up here. And then we're going to add 6 plus negative 3, which equals 3. And then we're going to multiply 3 times negative 3. We get negative 9. And then we're going to add 5 plus negative 9, which we get as negative 4. And then we're going to multiply negative 4 times negative 3, which we get positive 12. And that gives us a 0. So some of you might remember that if we're left with something at the end, that's going to be our remainder. And in this case, if there's a 0, do we have a remainder? Hopefully all of you guys said no. That's correct. We don't have a remainder. So we're gonna, and then you will have your next factor. This is a factor of x plus 3 divided by x cubed plus 6x squared plus 5x minus 12. And how do we put it into that factored form? So the 1 becomes your x squared value, and then since 3 is positive 3x, that becomes your x value, and negative 4 becomes your constant, minus 4. And that, if multiplied by x plus 3, gives you this, the original polynomial function. So your answer would just be that. All right, let's do the next one. So we have x cubed minus 8x squared plus 42 divided by x minus 3. So what is the first thing we need to do? Find out our root so we can use synthetic division, which is x equals 3, if you said x minus 3 equal to 0. So let's just write it in. Now let's put in the leading coefficients. 1, negative 8. Oh, well, we're missing an x. And we know that a 0x exists, so we're going to put 0 as a placeholder, and then 42. And then what do we do with the leading coefficient? It could be anything, but for all of these in this section, it's going to be 1. So we're just going to drag the 1 down. 3 times 1, 3. And what we're going to do, we're going to add them. So we're going to get -8 plus 3, which gives you -5. -5 times 3, -15. And if we add -15 plus 0, you get -15. -15 times 3 gives you -45. So now you're going to add -45 plus 42, and we get a -3. So in this scenario, you guys might think, oh, we have a remainder. Is there a way to put it in to into this format with a remainder? Yes, but we're gonna see that later on. And well, if we're gonna multiply x minus 3 back into it, what do we need to divide -3 by? X minus 3. So if we want to put it into there, you'll get x squared minus 5x minus 15 minus 3 over x minus 3. This would be your answer in synthetic, once you use synthetic division. And then if you want to get back into x cubed minus 8x squared plus 42, you simply multiply the whole thing by x minus 3. The x minus 3 disappears, so then you'll just left with 3 at the end. And since that's your remainder, it's going to be added back in to get you your original polynomial function. All right, let's do the third one. So what's our root? X equals -2. So we're going to put -2 right there. We're going to put 1, -2. And are we missing anything? Nope. So -5 and 6. What do we do first? We bring the 1 down. -2 times 1 is -2. Add them together. You get -4. And I want to stress that you're always adding these together. That's why you're putting in the root. You're never subtracting in synthetic division. And then -4 times -2, you get +8. Add these together, you get -5 plus 8, which gives you 3. 3 times -2, right, -6. So then we get a 0. Is there a remainder? No, we don't have a remainder. So what is our answer? X squared minus 4x plus 3. There we go. That is our answer after using synthetic division. So let's go on to the next one. What is our root that's given us? X equals -3. So we're going to put -3 right there. We're going to put 1, 4, oh, we're missing an x, so we're going to put 0 and 6. So we're going to bring down the 1. -3 times 1, -3. We're going to put down 1, then we're going to get -3. So -3 plus 0, plus 0 is -3. -3 times -3, you get +9. And then what happens when you add 6 plus 9? You get 15. And we have a remainder again. So what can we do? We get x squared plus x minus 3 plus 15, yes, over x plus 3. That's how we put a remainder into this form. And there we go. So now that you've learned how to divide polynomials using synthetic division, how would you find all the roots? Find all the roots of a. So let's write down the answer that we got for a. So after we did synthetic division, we got x squared plus 3x minus 4 times x plus 3 to get our original polynomial function, because we broke it down. Because x plus 3 is an actual root of x cubed plus 6x squared plus 5x minus 12. Not putting that in there would be a mistake. We'd be missing one root. So how can we factor x squared plus 3x minus 4? Yes, we can. And I've already done the factor, so it's x plus 4 and x minus 1. And then times x plus 3. And the whole thing is equal to 0 to find the roots. So x equals negative 4, x equals 1, and x equals negative 3. And that's how we find the factors, the roots of A. Now you guys are asking, well, can we find the roots of B and D? We can. We will learn that later on in other sections, but for now, we don't need to worry about that. All we need to worry about is using synthetic division to break down the polynomial function and setting it equal to 0, like we have done before, to get our roots. All right, so on to the second page. So it says, Andre needs help finding the x-intercept of the function, f of x equals x cubed plus 2x squared minus 7x minus 2. He knows one of the x-intercepts is 2, but there are 2 other x-intercepts that he cannot identify. What are all the x-intercepts of the graph of this polynomial? So we know that it's 2, so one of the roots is 2. We can use synthetic division. Now we need the leading coefficients of the original polynomial function. 1, 2, negative 7, and negative 2. So we bring down the 1, 2 times 1, 2. Add them together, you get 4. 4 times 2 is 8. 8 plus negative 7, you get 1. 1 times 2, 2 plus negative 2 equals 0. So our new function is x squared plus 4x plus 1 after using synthetic division. So now we have one of the roots. So all we need to do is find the root of this function. So we set this equal to 0. Can this be factored? No. We're going to have to use either completing the square or the quadratic equation. So the quadratic equation is, everybody knows it, but I'm going to choose to use completing the square. So I get x squared plus 4x plus 1 equals 0. What's the first step? I move 1 to the other side. So x squared plus 4x, leave a gap, equals negative 1. So what do I add? I take half of 4, which is 2, and then I square it. So I get plus 4 plus 4. So I get x plus 2 squared equals 3. Right? Because x plus 2 squared gives you x squared plus 4x plus 4. I'm going quickly through it because I'm sure that we went over it in previous lessons. If you have any questions, ask me the next time we meet up. And then I'm going to square root both sides to get rid of the square. Absolute value of x plus 2 equals square root of 3. To get rid of the absolute value, you do plus or minus square root of 3. And then you just subtract 2 to the other side. So x equals negative 2 plus or minus square root of 3. And that's all you need. You can leave it in this form. That's fine. And this is one of your answers. What is the other answer? X equals 2. Right. So those are your roots. What are the x-intercepts of the graph of this polynomial? The roots are your x-intercepts. So highlight that. That is the answer. So let's continue on to the next. So in this part, we are introduced to the standard form of a polynomial function. So we have the d of x, divisor, q of x, the quotient, and our remainder. So many of you are like, oh, well, what does this mean? So d of x is what we've been using to divide it by. And you've seen x plus 2, x minus 3, x plus 3. You haven't seen very many. Quotient is the answer we get when we use synthetic division, right? This answer, that's going to be our quotient. And the remainder, if we have some, is whatever's left over. So this is saying you can leave it as plus r. You don't need to divide it by x minus 11. That is standard form. But you need to signify that a d of x is multiplied to q of x, and plus r is on the outside, which you could do by parentheses. So let's get started. Let's jump in. Let's do part A. So x minus 11. So we're going to put 11 because 11 is a root. Leading coefficients. All right, let's bring out. Here we go. We get a 2 instead of a 1. So 11 times 2, we get 22. We add these together. We get a 1. 1 times 11. Put the 11 here. 11 plus negative 9. We get a 2. 2 plus 11 gives us 22. And if we add these together, we get negative 8. So our new function in this format, so let's do it. P of x equals d of x, x minus 11, times 2x squared plus x plus 2. Well, what do we do with the 8? Leave it out here. This is standard form for a polynomial function. So I could show you that it works by multiplying everything out and solving it that way to get the original polynomial function. You guys should do it. Do it. Let me know. Let me know what you get. You guys know how to FOIL. And you guys know PEMDAS, so you do negative 8 at the end. And let's continue. Let's do B. So we have x plus 2, so we're going to put negative 2 right there. What are our leading coefficients? 3, 5. Oh, we're missing an x squared, so that's 0x squared. Negative 4, and 3. So we bring down the 3. 3 times negative 2, we get negative 6. So that gives us negative 1. Negative 1 times negative 2, positive 2. Add those, we get 2. 2 times negative 2 equals negative 4. We add those, and we get negative 8. Negative 8 times negative 2, we get positive 16. Add those, and we get 19. So how do we put it into standard form? Hopefully you guys already know, screaming at me at the top of your lungs. X plus 2 times 3x cubed, because it's x to the 4th. We have only brought it down one more level. Minus x squared plus 2x minus 8. And then we add 19 at the end. And that's how you put it into standard form. So these, since it's x to the 4th and we're dividing it by an x, we're just bringing it down to the x to the cube power. And this is your answer. You could bring it down further if you had another root, but we're going to learn that in the next section. Or the section after that. One of the two. I can't remember. So let's solve for C. Use the original polynomial part A to evaluate P of 11. What do you notice for the first function? So if we plug in P of 11, some of you guys can already see it. P of 1 of 11 equals 2 times 11 cubed, because we're using the original, not what we found, times 21 minus 21, 11 squared, minus 9 times 11, minus 30. What does it equal? Negative 8. What do you notice? Gave us the remainder. Gives the remainder. All right, so let's do P of 2 of negative 2. So that's going to equal 3 times negative 2 to the 4th plus 5 to the negative 2 cubed minus 4 times negative 2 plus 3. So what do we get? We get 19. What does that give us? Gives us the remainder. Gives the remainder. All right, let's do D. Remainder theorem states that if a polynomial p of x is divided by x minus c, then the remainder is the value of p of c. So what I stated above, that why we don't need to divide the remainder by x minus c anymore, because it's already being multiplied, it's already been factored out. So what is the value of p of c if x minus c has already been factored out? Well, we've already done p of c up here, and what does it give us? The remainder. But if we want to put it in a function notation that works for all polynomial functions, so we put p of c equals r, whatever we get for remainder. What can you conclude if p of x is divided by x minus c and the remainder is 0? What have we done when we found out that a remainder is 0? Then it tells us that c is a real root. Right here, c is a real root if r equals 0. So c is a real root if r equals 0. And we already know that. And that is all for this section. Thank you for watching, and I'm gonna see you in the next video.